All right, we kind of started getting into chapter 3 yesterday, getting into imaginary numbers. Then we had some operations like addition, subtraction, multiplication with imaginary numbers. One of the big things you probably want to add to your formula sheet you guys could rattle this off. Who needs the quadratic formula, right? Just you can just rattle it off, right, Shane?
4AC.
That is part of it, yes.
Yeah, I don't know any more of it.
Okay. And you only really need to use the quadratic formula if you're going to have an exact solution or an imaginary solution. And what I mean by that is if you look at a problem like number 45. Number 45 says use the quadratic formula. And so that kind of is the big key right there, right? But in some cases you may not need to use the quadratic formula. If it was me, I probably would use the calculator. But when your answers are written as an exact answer, either they're going to be written with a radical or they're going to be written with an I. And that's something that your calculator would not give you. So that's why you would want the quadratic formula to be able to do ones like that. If I look at ones like 46 or 47, then I would just put those in the calculator, graph it, see where it crosses the x-axis. You don't have to use the method that they say. I know a lot of times as we've gone through the semester, I've told you, like, make sure you solve it by this particular method or whatever, but the final is multiple choice. So you solve it any way that you can solve it, okay? Whatever makes the most sense or whatever's the easiest. Vertex, not really a formula, but just remember that represents the maximum or minimum, so that's a calculator problem. When it says what is the vertex of the graph, we're talking about quadratics. We could do it with cubics too. When we did cubics, we had a maximum and a minimum in some cases, but in chapter 3, it was just one or the other. The axis of symmetry. There was the little formula that we used. X equals the opposite of b over 2a. Remember, and here's what I'll tell you. Can you use this formula? Yeah. Do you have to use the formula? Maybe, maybe not, right? But you could use your calculator. Now, if you look at the way the answer is written, for number 49, a lot of them are written with fractions, and so they want it in fraction form, so that's where the negative b over 2a would come in helpful. But also remember, your vertex is an ordered pair, and this number is the same as the number that I get when I do the axis of symmetry. Those two go hand in hand. The x value of the vertex is the x value for the axis of symmetry. So those two go together. So that's why you could graph it. You could find the vertex of it, and the x value of that vertex would be your answer. It just may not be in fraction form. So you'd have to be able to change that over. Okay, you've got some solving problems. You've got solving with rational functions, solving with a radical, solving with absolute value. Absolute value, remember, you're going to typically have two answers. If I had something like the absolute value of x equals 6, then my answer could be -6 or +6. There's two things that make that true. And anytime you have an absolute value equation, you want to keep in mind that there could be two solutions. The only way you would get one solution is if it's equal to 0, because that's the only one that doesn't have an opposite. And there also is the possibility of a no solution. If I have absolute value of something equal to a negative, that would be a no solution. Okay. But you got to get the absolute value by itself first. With absolute value inequalities, the two tricks that we talked about are less than. If it's a less than symbol, we're going to put an and in between. Or great or. If there's a greater than symbol to start with, then we put an or in between. It doesn't start off with two inequalities. It starts off with one inequality. We're going to write it as two inequalities. And when we write an inequality, we have to decide, is it and or is it or in between them? And so you have one of each type. 53 is one of them, and 54 is the other one. All right, so that's kind of the end of chapter 3. We're also going to get into a little bit of chapter 4 today. In chapter 4, we talked about all different types of polynomials, doing different things with polynomials. One of the ways that we named it was off of its degree. And so the ones that are the most common here, we could have a degree of 0, 1, 2, 3, 4, or 5. A degree of 0, we call it a constant. Degree of 1 is a linear equation. 2 is a quadratic. Those are probably the most common ones, especially linear and quadratic. We talked a little bit about some of the other ones here. Cubic, quartic. We didn't see too much of 5 or 5th degree, but we call that a quintic. If we get higher than 5, then we would just call it a 6th degree, 7th degree, and so on. Make sure that you go off the highest exponent. The degree is based off the highest exponent. Typically, that'll be the first one if it's in standard form, because a lot of times they give me polynomials in standard form, but not always. So make sure that if it's not in standard form, when you name it, you go off of the highest exponent, not always the one that's listed first. Another thing that you're going to see today, they don't use this, the leading term test, but when we talked about the leading term test tells us, or the end behavior of the graph. And there was a little chart that we came up with. The two things that we would need to know: what's the degree? Is the degree even or odd? And then is the leading coefficient a positive number or a negative number? Okay, and there's 4 options here. And all 4 options are going to be listed in your multiple choice. So you got to decide which one. Now, can I graph it? Yes, you can graph it, but sometimes we don't get a really good picture of what the graph looks like. And what we want to know is, what do the ends of the graph look like? that this chart kind of helps me come up with that without ever having to graph it. It's not wrong to graph it, but sometimes the graph may not give you the accurate description or picture of what we want. So just kind of think of some things that we're pretty familiar with. If a degree is even, that would be like a degree of 2, right? So that would be x squared. If it's positive, it goes up, up. If it's negative, it's going to flip upside down, and it's going to go down, down. So even degree, positive leading coefficient, negative coefficient is going to make it flip upside down. So it would start down and end down. If I have an odd degree, the most common ones that we dealt with was linear or cubic, degree of 1 or degree of 3. Just think of a linear equation. If I have a positive slope, it's going to start down and it's going to finish going up. If I make my slope negative, it's going to start up and it's going to end by going down. So those are your 4 options. And you can tell that just by using that chart. So that chart would maybe be something good to add to your formula sheet. Okay, and then you just have some graphing ones today as well. All right. I think I'm going to let you guys work.